Rotation symmetry is when you can turn something and it matches up to what it was before. So a circle you can turn an infinite amount of times, not a baby. And this one you could turn and match it up, 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 and so on. So you have to write the part that's missing in your notes, that a shape has rotational symmetry when it coincides or ends in the same place as itself. So for example, right, I'm going to take this, I'm going to draw over top of this shape. If I take it and rotate it, see how it matches up when I rotate it. And I could rotate it again, and it matches up again, and again, and again, and again, and all the way around, matches up one more time. So the number of times that a shape matches up with itself or coincides with itself is called the order of rotation. So here is our first important definition. It will work. As soon as I put the pen down, it's lagging today. Our first important definition, so I don't know if you want to underline it or if you want to highlight it yourself. So the order of rotation is how many times it rotates to match up. The amount of degrees. The amount of degrees that it takes for it to rotate and match up for the first time is called the angle of rotation. And here is the first formula that you have to memorize for this unit. Do you know that there's 360 degrees in a circle? So if something rotates 2 times to get all the way back to where it started, then the angle of rotation would be 180 degrees. Here's an example, right? This shape, I could rotate it. I'll draw over top, then you can really see how this works. So this green one, I could rotate it 180 and it matches up, and I could rotate it another one to get back to where it started. So this shape, we would say, has an order of rotation of 2 and an angle of rotation of 360 divided by 2, that's what the formula says, or 180 degrees. What about the shape that we just did? How many times does it match up? So we started here. Matches up once, twice, 3 times, 4 times, 5 times, 6 times to get back to where we started. So that shape would have an order of rotation of how many? No, it's 6 times as it goes around. And so we would say that the angle, what's 360 divided by 6? How much has it turned when you do it once? Can you do 36 divided by 6? 6. So 360 divided by 6 would be 60. So if something requires that you have to turn it all the way around, that it has no rotational symmetry, so like the letter T. If I take the letter T, right? It doesn't match up to be a T until I rotate all the way around again. We would say that that object does not have rotational symmetry. So we never say something has a rotational symmetry of 1 or an order of rotation of 1. However, there are some letters, like the letter I, if I trace over top of this, and I rotate it around once, it matches up. And then around again, back to where it begins. So this would have an order of rotation of 2. And here's the math with the formula, what the angle would be. If you did it 3 times, 360 divided by 3 is 120. 4 times, 5 times, 6 times, and so on. So if we take the letter S and rotate it around its center point, again, one of the strategies that you can use in this unit is if you take out some paper and lightly trace the same object on that paper, tracing paper works really good, and then rotate it around, you notice that it matches up when you're halfway. Tracing paper is paper that's extra thin that you can see through it. And then back to where we begin, which means this has an order of rotation of 2 and an angle of rotation of 180. So there's 6 shapes here for you to try. You can trace them on some scrap paper that you can see through if you want, or you can think about rotating them in your head to see if they would match up. For each one, say the order of rotation and the angle of rotation.
Are we allowed to answer?
Yeah, I'll give you the answers after a bit. For the first one, 2 is the order, 180 degrees is the angle. Second one, 4 and 90 degrees. So far, so good? Third one, no order of rotation. If you did it 180, there'd be black and white would be opposite of each other. So that one doesn't work. This one has 6 and an angle of 60 degrees. This one has 5 and an angle of 72 degrees. And this one has none again, because the one side of the kite is shorter than the other side of the kite.
That is mathematically correct.
Okay. Rotation around a vertex or center of rotation. So we want to rotate the following shape 90 degrees around the vertex C. So for this one, you're going to find it's really helpful if you take a piece of loose leaf,
That's a really good idea.
Oh, and draw it.
and on your loose leaf, draw it out. The other thing that's going to be helpful on your loose leaf is after you've drawn it out, on the vertex where you're going to rotate it, draw a little cross section which makes your axis. If we want to rotate something 90 degrees in the clockwise direction, Does it make sense that a point here would have to go down to there? Whoa. If you trace out the same shape on a piece of loose leaf and draw cross sections at the point where you want to rotate it, rotating 90 degrees in a clockwise section looks like this. So you take your paper, you turn it 90 degrees, and then match it up on that same vertex. That's where the shape will end up. So again, what happened is we took our shape, we turned it exactly 90 degrees, and then saw what the shape looked like, and we can draw it again. Some things that we notice on our paper, okay? If you notice this section here goes over 4 points, now this section down here will go down 4 points. When we label our image graph, where did the point B go? The point B went here, and we write B with a little dash to show that that's the new point B. This point A went here. We can write A with a little dash, and the point C stayed the same, so you can also label that so we remember where the new points went. I'll get you to do B on your own, and then we'll do C together because C is a little bit trickier. C uses a different kind of graph paper. All right, let's check how you did on B. So again, we'll take our shape. How do we draw a shape and rotate it? If we can copy it out over top and draw the crosshairs on the vertex that we want to rotate it. This time, we want to go 180 degrees clockwise. That would look like this. So you take your shape on your paper that you traced and you rotate it 180 degrees clockwise, match your crosshairs back up, and here is your new shape as a result of rotating it 180 degrees. If you don't use a paper and rotate it, if you don't trace it out, if you just try to do that in your head, it's pretty difficult. But using the paper and tracing it over top makes it easier. For the last one, it's on a different kind of graph paper. As Justin said, is my eyes screwing me up here, or these lines don't match up? On this graph paper, it makes a bunch of equilateral triangles where one of those equilateral triangles has an angle of 60 degrees. So here's our shape. We take out our paper, put it over top, and draw it out. Draw our crosshairs. Well, this time, actually, I'm going to draw the crosshairs like that because there's a bunch of points. Draw our crosshairs on this paper like that. Again, I'm going to take it, bring it off to the side. Now with our crosshairs like this, we want to rotate 120 degrees. One of these is 60. Two of them would be 120 degrees. So we rotate two of them. It's a little bit. See, where's my, I should do. Again, I'm going to, this point here is my first one. Again, if you label a point on there as a starting one, when you rotate it, that point has to be on that edge once it's been rotated. Then you can take your paper and draw it back, and there's the shape after it's been rotated 120 degrees. This will be the most difficult one that we run into. So there's a couple more on this page for you to practice, and then your homework is listed at the end at page 21.